My first video, official video to launch my product called a neck connector. First, let's start with the thesis, right? In today's AI world and AI system, it generates output and lots of jargon outputs, but they cannot be controlled, traced, or proven in productions. If something goes wrong, like I have felt lots of things going wrong, okay, there's no reliable way to answer. Like, I don't know how I answer things, but for me it's like a full of jargon jungles. Okay, why it did, what happened, whether it was meant to be trusted or not. Today, like, I don't know, I have lots of logs, but those logs are computer traceable. For me, it's not believable in today's distributed AI infrastructures or any infrastructure, autonomous distributed infrastructure. So to solve that problem that I was facing with my 5 years of jargon, headaches and all those things, I come out with connector proto OS system. What basically it does is it enforces decision before executions, record every actions and make every AI decision traceable and provable. Its core 3 features are isolation, control and proof for any AI decision workflows. So we can see, like, there are lots of codes. Okay, the main thing I will be explaining is the how actually the code is written, not the output phrases. Okay, so as it is, like, first of all, like, it has explained what is done and you will be getting it when you use it, right? So the first thing is, like, you are explaining, predefining the things, like prompt that will be a dynamic prompt when you use it in real world environment, like from system data import connector platforms that you are importing that, right? Then after you are defining, like, the tasks in the normally in real workflows it will be a dynamic tasks. Okay, and here what actually we are doing, we are using, like, Claude Code as a cell environment to interact with human. It's a coding workflows, and then connector as a central platform. Okay, and then it will be passing through, like, DeepSeek a LLM, okay, through connector gateway to get response for Claude Code as a cell. Okay, then and provide proof via a connector platform. First of all, then after you will define a demo, like CSL, so CCL source, which is a contract source, okay, which predefine everything. Okay, what you do here, we have defined a simple contract. Then after you will define all those paths and everything that we needs to be managed. Okay, like, normally these parts we can define dynamically if you know the Python codes, right? So, and then all those definitions and everything, okay, which will, these are all mainly outputs which you will be deciding as per your needs. Okay, backend is solidified already. So this is how the codes are written. The main thing was import, okay, then defining contracts and defining paths and everything, or predefining the environment. So after you do that, you are ready to use connector. Okay, then after all those outputs and everything is made to make my life easy. So let's start terminal, new terminal, right? So here I will be using a make configuration, so it makes my life easy. So make put already demo it has been put it before, sorry, in demo the 2 file only. So okay, and let's starting, so it's asking the deep, right? So API. I don't want to go in the UI side in the beginning. Let's do the demo first, then after I will show you the UI side. Okay, so you can see, okay, it has already booted, and then the agent is already started, and all those configuration we have set up has already started. Okay, so it's running in the host that it's already shown, right? So the client is Claude Code. Okay, and Claude Code, where it's, and like it will show the path home is like local has been Claude, right? So which Claude is using 2.1.92. It's a cell. It's not using Claude as a LLM, it's using Claude Code as a server cell or user interface, right? So authentication is using connector API, like it's already there. Okay, connector gateway it's using. So like all the health score right now is 0 because it's not performing kernel level interactions. Okay, one started, it automatically started lifting up. Okay, so it's the first boot environment. Agent limit, as it is a ND, agent limit is 3. Agent packets is like 100 packets you can use like agent use is 14. Normal, like is a normal, for normally limit is 3, but the agent you will be provided is 14 packets, like packet limit is 10,000. So all those things are informed. Okay, so and then contract ID, the contract we wrote before, CCL contract using Python, is burned as CLS1 hash number is this. Okay, govern coding demo. So version is 1, block, how many block count are there? 5 block count is used, similar kind of versions. Okay, so normally it's a what are all those things which are exported. Okay, so basically it's a workflow diagram. Okay, how it works: plot code cell, developer facing cell that I already told you, right? Then connector gateway, which take you to the LLM, which control LLM interactions with the agent. Okay, then control panel, which all manage context assemblies, Rigsgate, review lanes if needed, and all those firewall jungles and deterministic policies and firewalls, blah blah things, right? So the provider here I am using is DeepSeek. Doesn't matter which provider you are using Olama, you are using APIs, you are using anything, it has all those routes, you can directly connect and use it. Okay, the fact here is not LLM is a control panel, so doesn't matter whatever you do in the left side and right side of the things. The major workflows would be, initially there will be a tool or injection platform, then then there will be a control planner. In the top side there will be any LLM that will be controlled by that control panel. Okay, 1 or 2 LLM or a substitute LLM, whatever would be there, the configuration setups would be used. The third side would be output or the tool execution, that will also be counted as output. Okay, so all those things I don't have to explain. Okay, it is showing how much time it take to boot it up. Okay, it's a booting thing, and decision proof. Okay, the like what started, it's the proof of agent has started. Okay, and it the starting decision, receipt links and everything is there. Okay, so it's tracing everything. So let's start with the first workflow. Okay, so it's like it's running, and then as started, and the first decision what it did. Okay, the decision receipt link is here. Okay, and then you can trace that receipt link, okay, using the connector CTL, and see what actually it's been behaving. Okay, so you have you can go back and see what actually happened. So let's go for another workflows. Okay, so this is the another workflows. Okay, what it like self governance. Okay, like self govern a success, like what actually it did is post, this is the policy check, it is policy checks and decision record. In this section, before going to having an action, okay, given action by agent to LLM, it has done the policy check that you have defined and the decision record. Okay, and then decision story. Okay, risk level, if its risk level is low, policy allowed and bounded and written. This is what actually has happened in the low level, right? So the proof is like that. Decision result. Okay, decision allowed, decision ID is this, and policy is policy dot part, the scope that allow. Okay, receipt generated for this specific decision is this, and verified is true. So what was the file that was like touched was response.rs. Okay, platform/server/src.models.response.rs. Okay, the token use was 462. Okay, as it's a real API token that has been used, and token estimated cost is, for as per DeepSeek, 0.0035. Okay, so let's go for next slide. Okay, so this slide answers the boundary deny. Okay, self alternatives. Okay, like if it's really denying the unsafe things or not. Okay, so same thing what it did was post API version 1, like PID, it was like it's the isolation similar to like proxies that is done in the OS level for hardware to logic operation interactions, okay, for it, but it's for the AI logic use. So it's doing everything. Now what happened, let's see the decision, right? So decision here: resource platform server the secrets, risk was high, action was denied, deterministic, okay, data exposure was prevented, and model override non gate is non prompt driven. So what was the actual decision that was taken, right? So decision was deny, okay, it was hot deny, then resource was the thing, policy was this, and received was this, and the verified was true. And this is not done by any LLM logic or interference, it is done by the contract you have written, okay, and then what you have allowed to do, what you haven't allowed to do. So it's predefined. It's not like you are giving AI to define this, you are defining as a human or as a coder. So everything what AI is behaving is controlled, and you know what's happening, and if something goes wrong you can prove what has happened. Okay, so let's go for the third workflows. Okay, so it's conditional review path, okay, so it's review, like what it's using is post this is thing, okay, so and then so what actually has happened, like risk classifications and everything is explaining what is there, okay. So system state, so pause, hard stop, preserved and disable until approval, okay. So the main decision was decision review required, platform shared RS SRC that's shared, policy was like model review, received and verified. So actually what happened was this, okay. So let's go for like how we debug or interfere with the system, okay. So now this is showing operator proof, okay, what actually will be happening. So decision layer, this is decision layer of like what actually has happened, allow, deny and review required. And this is workflow, in real workflow, okay. This is just not one slide that you are seeing, the one decision output will be for each action that is happening. So every action will be generated that, okay, and it will be according to your CCL contracts and all those logic you have been included inside connector using connector kernel and connector engines. So and all those tokens and everything you don't have to see, it's like price will be automatically increased. Right now it's 462 tokens and estimated USD cost is that, right? So now this here like CLIs and operators, like what are the CLIs we have, like cloud code cell, okay. So connector CTL trace pit 10, you can trace it, explain decision and prove decision. We have lots of other things you can use connector CTL help to understand that, but for now we have used those, right? So for example trace, when you trace it you get this, okay, that is trace ID, okay. Explain decision ID this, policy hit, policy path scope deny, outcome deny, proof decision is hash, and then the hash reference chain head is received. So whatever is happening, okay, you can directly use connector CTL to check as a operator, okay. So now end of the government like flows, okay, then you can see the chain head contains has and platform signatures, okay. So at the end you will get the you will get the thing, okay, you will get this proof, okay. I want to show you the proof. So this is the proof what it generated and it will be kept as per the record, okay. So and then you can verify anytime, and using this proof of record only you will be getting all those compliances reports and everything, okay, that I will be showing you in the UI side of thing, right? Like now I will be going sort towards the UI, okay. So let's go sort towards UI, okay. I'm using a dev mode, dev bypass, okay. I'm not using the verifying. The first thing you will see is this: the trust code in the current scenario of the system is 64 and it's real backend, okay. Live monitor is unavailable because it's using in the dev mode. In the production mode you will get a live verification. It's for security. It's unavailable in the dev mode. Okay, so what actually it did was like this. All of those, most of the things are denied. One success, 3 denied, right? So it's writing the memory packets. So how much time it was, like as is in the dev mode, I run in front of you. Okay, so the status is healthy, uptime 0 hours 10 minutes and 36 seconds. It shows how much time it has been run without any breakage. So version and the node is connector nodes, right? So agent, like here, okay, it's showing healthy, degraded and everything. You can see that. Okay, so I will be showing graph. Okay, so not the graph, I have to show monitor, I guess, right? So see, the more you can see all those monitor details, okay, what has happened and everything, and it's the real output that has been taken by backend. Okay, it's not like the mock datas. Okay, action logs, okay, violations, there are no violations and everything, so there is nothing in the report. Okay, so journals and everything right now is pulling the data, but it's in the dev mode. It requires the tires, okay, to execute real kind of informations as per the requirement. So let's go for debug. The most important thing here will be a debug. Okay, so debug. Okay, so trace, the main thing is debugging trace, which is like, see, the agent, UI test agent or whatever, not this agent. Okay, clone agent, yeah, agent 10 1 2 3 7 10. So this is the thing, load. So you can see that, okay, what happened every execution. So audit IDs, timestamp, everything, okay, target, timestamp, and everything is being recorded. Gateway LLM captured, denied outcome. So everything what it did in that workflows has been recorded. And here we have to understand one thing. Okay, I just show you the 3 workflows. 3 workflows is 3 action. Okay, every action will be generating similar kind of output workflow. For example, you are doing coding, right? In coding, for example, when you are writing a one code, there might be a 4 to 5 workflows, right, in the same writing of code. Might be it will go to the one page, it will read that page, okay, it will do this, it will do that. Okay, now according to your backend logic, you have given access. Okay, for example, think about a condition where, okay, there are 3 people, a senior dev, dev OPS and a junior dev. All 3 are using Cloud Code. Currently Cloud Code have enormous power, but all 3 are giving same power. Now junior dev doesn't know, okay, how to handle secrets. He asks to a chat GPT or whatever is there and say, okay, blah blah things, how to do it. Okay, and then he implemented using Cloud Code, and Cloud Code did it as for junior dev, and something goes wrong. Okay, now for senior dev is like a headache, right? He has to fix that. Whereas if we have a control layer that define what a junior dev can do, what a senior development person can do, what a dev OPS can do in a kernel level attestation, okay, without giving full power to all of them, only the power that they need, then our development environment will become more strict and more usable and less risks, because we can trace back what happened every actions. Okay, moreover, it's a infrastructure, so it's not about just development. It can be used in any workflows that where we have LLM to understand and execute things, plan things, and then the execution layer as an agentic framework, memory and tools. So all of those things is controlled, managed, debugged, proof and given proof by this system. So the basic work of this system is that. So all other things I don't want to show in the UI, it will be going so long. Okay, so the main thing has been understood. Okay, in the current situation, okay, I would say that this system as a initial version of, okay, proto OS for agentic infrastructures that can manage your memory, that can manage the execution, that can manage what things will be given access to LLM to execute the tasks, what is not allowed, and a role based access control, but in agentic human augmented role based access control using the thesis of cryptographic chain of custody. Thank you. This was the first demo in the YouTube channel. Okay, in the series I will be bringing lots of other things, okay, explaining how this infrastructure works, what is it